All right, time is 7 o'clock. So, very good evening to everyone. And we have with us our resource person who has already joined just now. So, once again, so this is the final session of our 10 hours program on beginner AI certification programs. And as Mitra sir rightly mentioned, that we will have intermediate and advanced level also in the coming days. We'll discuss and plan it properly. We'll let you know, and I would like to intimate that the all the certificates will be sent through email. Please give us, today is the last day. From tomorrow, 3 more days, and we'll try to finish it before that. But still, no, I'm asking for little more space so that we can do the things correctly. Thank you once again, and thank you, Mitra sir, for your support, time, and wonderful sessions. I'm sure that we all are benefited out of it. And I request Mitra sir to kindly please take over the session. Thank you once again.
Thank you, Mr. Sir, for introducing. Okay, good evening once again to all of you, all the participants present today. So, as this is the final session for this particular training program, and as we have mentioned, that today also we will be doing some kind of a hands-on practical exercise with the rapid miner tool that I was discussing yesterday. So I hope that, as I have mentioned in the previous session, you have all successfully installed that tool and you are with it in front of your desktop computer or laptop computer, because I will once again request all the participants that be ready with this. Otherwise, you won't be able to just check how the things actually are done through rapid miner, how we can generate or create models, ML models or prediction models, like classifier or regressor, something like that. So before I just directly go discussing that particular tool, today some more important things are left which I need to discuss regarding data pre-processing, as I was saying. Because before we directly delve into that creation of prediction or any kind of analytical models, we need to do some homework, or before we feed our data directly into the model. So those things are very important to understand. As I was saying, why this is important, that answer will be you will be getting after this discussion as well. So I think participants are also joining one by one, all, and so I hope that while this presentation will go on, you will be listening to me, uh, and if you have any queries, you can ask then and there. But at the same time, make your tool or the software, that is Rapid Miner, ready with you. So let me share my screen. Is my screen visible? Anyone please confirm?
Yes, sir.
Okay, thank you for confirming. So today, before I just go into discussing or developing a no-code AI model, one more important part, rather I will be saying one of the most important means part in ML design pipelining is data pre-processing. So as the tag, it is clearly mentioned here that from chaos to clarity, as we know, and this is one of the foundational concept. Pre-processing means what? before the data is processed by the ML model, you need to process it earlier just to make it ready for the ML model, any kind of ML model. So what do we mean by actually processing, pre-processing, and why it is required? Because see, for what I say, for learning purpose, for demonstration purpose, or just for practicing some means academic projects, most of the students or researchers do what? They just go to the Kaggle. This is one of the most popular website, data repository, we can say. Many data are also available in GitHub. So they just go to any of the data repository, download the data, and then after some pre-processing, they feed that particular data into some ML model for prediction purpose or for analytical purpose. Now, in real life situation, what happens? The data are directly taken from the environment. Okay, so as I was mentioning in the very beginning sessions, like any AI agent directly interacts with the environment. So whenever any AI agent will be directly will be available in an environment, it will interact with the environment with the help of sensors. Now, from the sensor, it will collect some data and information, and in some other models, we just download, we just prepare the data early and then just give it to the model. But whenever from real life environment we take the data, it is not ready for training. So this is very important to understand, because as you know, the sensors or from where actually I am getting the data, either for marketing data or for business data. Most of the data are dependent on what? Dependent on survey or other kind of feedback, something like that. So as you know, suppose for a review of a particular product, so in many cases you cannot assure that everybody will be giving you all necessary information. Okay, so suppose a few of the customer will be giving you, suppose if you are asking information or feedback for 10 necessary fields or domains, now you cannot make all those domains as mandatory, as you know. Now few customer may feel like 8 or 7 or 8 required means options out there, and they will provide information for that. They may leave 2 to 3 information as a blank. Meaning what? They are not always means for they are not always bound to give you all the information. So what happens in this situation, whenever you will summing up all those feedbacks and survey in some data set, like maybe in CSV or Excel sheet or some other formats, you may have different problems. Like one of those important problems are that's blank entries, like where the informations are not available, so the missing values. So this is one important thing. Another important thing can be there, like that for any particular data set, uh, if I am suppose if I am giving the any numeric values as a feedback, or any data set is having any numeric values, so the range of those numeric the range of those columns or those fields with numeric values is very important. Okay, why I'm saying? Because as the range will be high, it will be very difficult for any kind of ML model to keep track or tackle those particular columns. So as I was also mentioning maybe in the previous session somewhere, suppose if any particular field, suppose price. Okay, so price, it may be the situation that price may range from rupees 100 to rupees 1 lakh, for example. So this is a huge range. Okay, so if I am collecting information from 1,000 customers, and if 500 of them have given the data, that price value, maybe for some product or something, I'm not discussing that particular, it may be anything, reason may be anything, but they have given information about the price field somewhere about regarding 500 to 600 customers has given the price range from rupees 100 to rupees 500. Some 100 or 200 are given the price range from suppose 10,000 to 50,000, and very few have given the price range of suppose 50,000 to 1 lakh, something like that. So the range become huge. So whenever there is a huge difference, okay, then whenever we statistically look at that particular data field, we will be finding that the mean, mode, and standard deviation that we normally look when we just try to find out statistical property or alignment of any particular data set, we'll be finding a huge standard deviation in that particular cases, because the range is very high. So this in turn will create a problem in machine learning for any kind of model, only because that it will take much time to converge, or means to minimize the error. So this is one situation. There are some other situations as well. I will come one after another. So the thing is that before we go for like any kind of ML model training, we need to take care of those problems. Because if we just directly give the data to the ML model, then there may be some problems. Okay, so we have to take care before we just go for training any ML model. So the first thing is that, as I have mentioned, that in reality, all the data that we will get are messy data. So I cannot say, because that's why now the problem is challenging. And whenever the problem is challenging, that is the particular area where we can apply artificial intelligence. So missing value, as I have said, that this is one of the problems. Another problem may be the inconsistent formatting of dates and like years, something like that. So one example you can find here in the slide, it is mentioned. In some cases, I have said that some outlier, okay, maybe wrong information, isn't it? A price listed for any particular t-shirt, suppose a dollar 10 million or something like that, 1 million. So it may not be possible. So my data set may also have some outliers. Outliers means, you all know very well, that that particular data points which does not generally match with majority of other data points. So the most important thing we have to always remember, that data is very important. So if you do not have proper data, proper processed data, or data in well-structured data, and if you directly feed that particular data in my ML model, unstructured, unprocessed, data unorganized, directly in my ML model, then that ML model will not perform well. So that's why in ML terminology, in AI terminology, we use a terminology called garbage in, garbage out. So if you give a garbage data in an ML model, obviously your output will be also a garbage. It will be of no use at all. So we should have to ensure that whatever we will feed into my ML model is not a garbage one. So that's why we have to take care of few things, few steps that we need to perform at least, and those steps are known as data pre-processing. So that we will discuss. And major consequences, as I've already said, that if you give raw unprocessed data in our machine learning models, the results are basically catastrophic, will be of no use. And in many cases, if you have missing values, the algorithm can fail as well. It will suddenly stop or crash. So to avoid all those situations, we need to take care of this situation, and we need to pre-process the data before we move. So what is data pre-processing then? So data pre-processing is nothing but a technique of converting raw, messy data into a clean, understandable, and formatted data set that machines can interpret. I think it is very much clear. Now, the target is, whenever I will be getting a raw data, I will be converting that to the model-ready data, that is clean, integrated, and transformed. And obviously, what will be happening if we process the data properly? The accuracy of the model will improve. The efficiency of the model will also improve, that it will reduce training time by removing redundant and some other irrelevant features, and also compatibility. It will also ensure that like data fits the mathematical requirements of algorithm. Okay, so like some cases, if I am dealing with a statistical formula or something like that in my algorithm, so I have to always ensure that I do not give any kind of character data set or string data set, because my numerical function cannot process those string data sets. So these things we have to keep in mind. So data pre-processing will ensure that such things doesn't happen. So data pre-processing pipeline, if I say, we'll be having some different approaches, some sampling data approach, noise data and structured error analysis. Then we sometimes perform some machine data analysis and treatment, outlier analysis, then feature engineering approach. So these are the different approaches. Basically, sampling data approach means, suppose if I am making a survey, one example very briefly and quickly I'm doing, because data pre-processing is also very important whenever you design any model from scratch, and before that you need to collect data. So if any marketing organization is doing any survey, market survey, so they will approach suppose for any particular product which is like for like male customer as well as female customers. Now you have assigned a person or few persons who will go into the market in various different cities, or very different region of any particular city, and will interact with the like different boys or girls, or men or women. So they will collect data from them. But here they have to keep in mind one important thing. So if the product is for both male and female, so if they are surveying 100 customers, so they need to ensure that in that particular 100 customer data set, at least 50-50, though it is strictly not possible in many cases, but at least 50-50 means sampling ratio should be from men and women. Like if I have interrogated 100 participants for that particular survey, so 50 from at least approximately 50 from them will be from men and other 50 from the women. So this ratio, sampling ratio, should be like balanced. It should not be like that I was asked to interrogate 100 customers or 100 people, but I have also taken the 100 survey, but 80 of those are from men and 20 from women. So this data will be highly biased. So you may say that I have got 100 survey reports, I have the data set, but whenever that particular survey or that particular data will be given to that particular model, so it is bound that the biasness will be towards the male customers, because in my training data set, whatever I have taken, majority of the participants were male participants. Okay, and you can always find like this. It happens in our real life situation as well. That is called bias and ethics in AI, in generative AI, in Google search also. So all of you can. I'm giving a very means good example such that you can understand the effect of bias. So you all are aware of the word nurse, okay? Nursing related to the medical terminology. So nurse, can anyone tell me that is there any gender relation with nurse, this profession? I think both male and female can become a nurse, isn't it? But our normal conception is nurse means woman. And in most of the cases, wherever you find a record, you will be finding that nurse is basically a profession for women. So that's why whenever you search in Google for any nurse images of any nurse, so you will be finding majority of them will be women. Okay, so this is a very clear-cut examples of that particular biasness. And whenever a generative AI model is trained in those particular data sets, because it is biased, the concept of nurse is biased towards female profession. So as well, generative AI model is also trained on that particular biased data sets. So whatever reasoning they will be making, those models will be making will be also bound to be biased. So this is a consequence that we have to means understand. Okay, so we have to stop this particular thing at the very beginning. So data sampling bias should be avoided very well, because whenever I'm doing some kind of classification, because the classification needs supervised data, and supervised data means there is a data set with label. So if I am I am collecting a data set for two different levels, so it should be 50-50 ideally, but it may be something 60-40 or something like that, but it should not be 10-90 or 20-80 or 30-70 like that. So this is called sampling. Okay, And noisy data, I have already mentioned the data with missing values, with some means outliers, which range or some other garbage values, some like what I say, suppose in the name field or something, string information, some unknown characters are there. Okay, so which are not easy to interpret, or symbols are there. So this can happen as well. So those are the things we have to understand. And another pre-processing approach that comes, we know as that feature engineering approach. Feature engineering means approach means whatever the data set that I have given, okay, then I have, from those particular feature set that I am given with, I am trying to devise some new more features which will be more relevant. Like some more features, like it may be a new feature. Okay, so that suppose I have in a data set I have three features. Okay, now with those three features I can devise a new one feature. So that one new one feature may replace all other three features or three columns in your data set. This may also this may do different advantage. This is having one advantage, may have that uh, the dependency between those three, if they're interdependent, so that dependency will be removed. So in place of three different columns, I am getting now only one column. Okay, so this is called feature engineering. One example I am giving: suppose I have my what I call height, I have my mass, means weight. Okay, so from this height and mass I can calculate like body mass index, something like that. Okay, so this BMI that I am talking about is a new feature which I have engineered from height and body weight. So this is more maybe more important in some case, other diagnosis or other purposes. So whenever from some existing features I am devising some new feature, and which will be actually representing all those previous features, this type of feature set is known as feature engineering. This type of effort is known as feature engineering. And feature engineering is very important in some cases where we try to combine two or three previous features to a new one. So this will reduce the number of features at the same time and also add some more meaning to that new feature. So this is a thing. In some cases, dimensionality reduction. Dimensionality reduction means, in many cases, I have like different, means what I say, very large number of feature set. Okay, suppose for any particular stock prediction model, I have got a data set where number of features is 1,000. So this dealing with large number of features or columns in my Excel, what I say, it will automatically, it will make any kind of learning process slow. Okay, so more features mean more slow algorithm. So you should be sure about this. But it is also true that not all features are similarly important. Few of them are important and few of them are less important. So because in the beginning, we may not have some idea, like I cannot directly say that those features are not important at all. So if it is, then I can directly remove it. So dimensional reduction, what I'm saying, it's something like, it's different. It's not that if you find that in a data set any particular column or any particular feature is irrelevant, you can directly discard it. There is no problem. Okay, but you may also feel that whatever the feature set I am getting, all of them are important. It's not that you cannot discard directly any of them, but still the features, number of features is very high. So in that case, one statistical methodology is there that is called dimensionality reduction, where we try to reduce the number of features without losing the meaning of the data set, means some statistical balance of the data set. Okay, so for that particular some methodology is there, some like we also have what we call some unsupervised learning algorithms to do this particular thing. Okay, so some statistical method are also available where we try to reduce the dimension of the data set without losing the integrity of the data set up to a certain level. So this will make one thing that if when I am not losing my integrity of my data set, what will happen? It will not impact my overall accuracy or efficacy of the model at a large level. Okay, so just little bit compromising my efficiency, suppose maybe 1% to 2% compromising my efficiency, but it will increase the speed of my training to a huge extent. Okay, so in that case, if this is the case, we are sometime we consider that approach and we reduce some feature, okay, based on that particular dimension reduction approach, and then give it to the data means processing models. So one simple thing that we will often find, that is data cleaning, missing values. We will be finding that in many cases we will be find that many columns, many values, many cells are null or nan, like not available or something like that. So before we give that particular model, we may have to remove. We have to at least make some arrangement with this, because you can find here in the example that in this age column, three columns are already given with some numeric values, but one is missing. So what I can do over here? Okay, that I have to understand, because this is this decision you have to make. Nobody will else will make it for you. If you ask generative AI, it will give some general answer. Okay, it will be giving, but being an expert researcher, if you are from your particular own domain, and if this data set is from your domain, then you are the person who will decide what to do with this missing value. So this missing value can be dealt using different approaches. Okay, one of that approach is like deletion. Simply delete that particular row, okay, which is having missing value. So it is simple like that. That row is not there, so that means we will not face any kind of problem. Okay, so this is one approach, but you can afford deleting rows or examples. Actually, in machine learning terminology, when we're learning, we call these columns as features, and these rows are what? Examples. So if you have huge setup data set, okay, with like means huge number of examples, then you can afford that. Okay, suppose if you are classifying your customer based on like feedback. Okay, you had launched a product in the market, and now you have got a report. So based on that particular report, you would like to classify how many of them were happy with your product, or how many were not. That particular data set you are having now. Next cases, you will be using that particular data set to train that whenever you will be launching a new product in the market, how much percentage of people will be happy or not happy, something like that. So in that case, if you have the record of suppose 1 million or 10 million customers, then you can afford deleting 100 or 200. Okay, but if suppose if you have the data set with only 500 or 200 customers, so in that case, deleting 10 or 20 odd rows, which with this missing value, is also will not be a good idea, because it will again reduce your data size. Okay, isn't it? So in that case, what we do, we replace it. For replacing that particular data set, we may have different options. One option is called imputation with mean or median. So we calculate the average of all other data that is available in that particular column, and we replace all the missing values with the average or mean of that particular column. Okay, so this is a very good option, and this option is available, maybe suitable for age, income, or something like that, but may not be suitable for some other cases. So that will be, you'll be able to understand by checking the column name or column description. We can also impute that data with the help of mode. Mode means you will fill that particular value with a frequent value. For categorical datasets, it basically categorical, numerical dataset may come in two different ways: categorical and numerical. Numericals means like age or something like that, where some numeric values are available. Okay, but categorical dataset can be which is having some linguistic entry. Okay, like suppose language, if I am talking about a category, so maybe, or religion, so Hindu, Muslim, Christian. So these are different entry or categories. So if you are having a data set with religion of different people, so in that particular case, you have some missing elements are there. So in that case, you may fill up that particular data set with that religion with m maximum times in your data set. So that is called actually the mode, filling with that particular imputation with mode. Okay, so another thing is there binning. I will discuss that later. Binning means grouping the data sets into some specific fields. Okay, so it will make your data set more model training friendly actually. So smooth the store sorted data by looking at neighbors, and it groups the data into buckets to reduce minor observation error. So it makes the data set into some buckets, fields, or like bins we call. Then in some cases we apply regression also to feed the data. It also regression also comes under sometimes in data cleaning. Outlier removal, as I was saying, it's very important because this one or two outlier can make damage your data set, and it will drastically like influence the performance of any ML model. So outlier removal is very important. So any data set, if you put in a scatter plot, and you will be easily detecting that are the outliers. So outliers means which will be very far from the central region of the data set, very far. Okay, so that identification is very much important. It's very means advisable that you just directly remove those outliers. No need to impute, no need to tackle those data sets. Simply remove it. And some other cases, data integration is also required because this is a different part, may not be that much relevant for today's discussion. Whenever I'm integrating data from different platforms like a different cloud or maybe my local database or some API, so that combination is very much important. Normalization is another thing. Normalization is whenever my range is very high of a data set. So this normalization does what? Normalize make all the data in a particular range. So maybe my original scale of my data set is from 0 to 10,000. So normalization, one of the example is mentioned over here is min max normalization. It does what? It rescale the features to a fixed range of 0 and 1. So if all the data in a particular column within a fixed range, it is very, and that is a lower range as well. So it is very easy mathematically and computationally to deal with that particular data set. So normally min max normalization and z-score standardization is also there. The z-score standardization is very effective in most of the cases where we just rescale the data such that the mean of that data becomes 0 and standard deviation become 1. So remember, I am repeating this z-score standardization because we will be using in our tool today that z-score standardization, which rescale the data to have mean 0 and standard deviation 1. So z-score standardization is another approach. The purpose is only if my range is high, my model may face some difficulty due to this high range. So with the help of normalization, we make the data, all data within a proper fixed range and a small fixed range such that my model can interpret it properly. Some categorical encoding is also there because in data set many column can be numeric and some column may be what? Linguistic. Okay, like the raw categorical data here I have given the field is there like color. Okay, color red, blue, green. Suppose I have the data set of any particular dress item. So dress item data maybe the price, maybe the number, maybe the size, different things will be there. But with the same time, a column may be available that is called color. Okay, so you can easily understand all models are my numeric models, are my statistical models. So statistical models cannot actually deal with categorical or means linguistic data or text data. So obviously at the end we have to convert those categorical data into numerical data. So one option can be that because for any training model for computer, it does not mean whether it is red or blue or green because it does not identify. It only knows the difference or the variety. So one approach is there. If there are very means if the number of categorical variable is less, then you can directly replace with some numeric, like 1 for red, 2 for blue, 3 for green, 4 for suppose yellow, something like that. Okay. Or what you can do, but the second option I am telling you, but what will be the main problem with this type of approach? So if suppose I have 10 different category of color, so obviously the first color I have to give one and the 10th color I have to give as 10. So what will be happening whenever the model will be interpreting this particular column? So it will be 1 is 9 less than 10. So 1 value is less and 10 value is high. So automatically the model will learn that as the numeric value of this red is 1, so red will be taken as a lower priority, and wherever the value of that is the 10th color, it may be cyan or something like that, so that 10 value can be given as a higher priority. So though here there is no question of priority because all they are colors. Okay, so actually in my data set I want to represent that all the colors are having the same priority, but due to my encoding, due to my interpretation, automatically red will be treated as a less important, and that particular cyan with the 10 value can have a but the more important or higher importance. But to get rid of this particular problem, another type of encoding mechanism is there, that is called one hot encoding. So this one hot encoding, it just spreads that particular sheet. Okay, so suppose here I have three colors, so I have made three different rows, sorry, three different columns. Okay, and wherever the color is red, I have made the red column to be 1 and other two column as 0, and wherever it is blue, I have made the blue column to be 1 and other two 0. Whenever it is green, I have made the green column to be 1 and other two as 0. So what is the advantage here? You can easily understand here that all the colors are given the same importance of 1. Okay, so here I am not giving any model any other means an extra information about the importance of the color. So this type of encoding is actually advised whenever you have the categorical variable number of category is high. But one thing can be happening here, the here the number of column will increasing. Okay, so if there is a 10 means 10 different colors, so we can easily understand 10 new columns I have to add over here. So it is a computational burden which we have to take care. But computational burden and there is a accuracy trade-off, so we have to select one. So as my computation heavy, as we have now means what I call means sufficient computational power, so we can afford this type of encoding as well. So data reduction I have already said. Okay, so some example of dirty data set I'm giving, so which I need to, so you can easily understand what are the data preprocessings I have to do for this location. I have to make it from category to the numerical values with the help of encoding. For there is a missing, so I have to impute this missing element maybe by mean or mode, and here also number of 5, so I have to make it from text to numeric values. So this may be the case as well. So the process is clean, encode, and scale. Clean, encode, and scale. So keep in mind. So this is a good example of a clean data set where I have converted all the categorical variables, linguistic variables to a numeric data. I have imputed the missing values here with 0 and here with suppose 5. So this is an example. So finally, what we can consider that preprocessing is not optional; it is a mandatory thing, because once you do not preprocess, your data will be a garbage, and if you give garbage to a ML model, it will produce you a garbage result as well. So garbage in, garbage out. You have to remember, and the pipeline to remember is clean, integrate, transform, and reduce. Clean, integrate, transform, reduce. So it may not be the case that everywhere all the 4 stages will be required. No, based on your means accuracy of your data set, you may have to select 1 or 2 of the available modeling approach or available approaches. So do you have at a stage I have said many things. So if you have any question regarding this or any confusion, or if you'd like to add anything, you are welcome. So do you understand what was the purpose of this discussion? What is the meaning of data preprocessing and why we require data preprocessing? Any question? So probably you don't have any question. If you have any question, you can also ask in the chat box. Okay, very good then. So now I want response from you whether the tool Rapid Miner that I was telling is ready with you or not. So how many of you are actually have those that particular tool ready? It's not only me. If you also do some things and give me the response or your feedback that whether you are accustomed with that particular tool or not, I'll be happy to like clarify the problems what you are facing. So are you ready? In the chat box, please respond with that how many of you are having that particular rapid miner ready with you in working mode, means it's successfully installed. Am I audible?
According to the model, the consider number of electrons present in each cell of an atom called
Okay, now I think all of you can check my screen. Is it visible?
Yes, sir.
Okay, good. So as I have said, I think those who have got some time, you may be very busy on Sunday because we have a lot of pending works. So if you will get time, okay, whenever you'll be getting some time, you just try to explore this data set. Today I will be going through some tutorials, and at the end we will do a small project directly downloading the data from Kaggle and means running some ML models. So but as I have already said, this tutorials are very helpful. So once you go through or complete all this tutorial, you will be getting a full idea about this particular model. So this is what I said, that uh, the best option in learning this particular tool. But always remember the steps. Okay, whenever I talk about, because this starting phase of this tutorial is get started, there are 8 different sections. Those are just to make you accustomed with that particular tool, and prepare data that I has already was saying about data pre-processing and building a model. So these two are the most important, and I will discuss here today. And I think this data getting started portion that I have said, you will be doing by your own and you can easily understand. But only one thing you remember, that I have also already discussed yesterday, that how to access data and import data to the repository. So those who have forgot or was not present in means yesterday's session, they can have that at the left hand side. Here there is an option called import data, and you can remember all these are different boxes or tools which you can move and keep it any different part of that screen, because here four windows are very important. Okay, one is the operator window, So this operator window will do what? Operator window, all the different operators or functions, like for data preprocessing, for data modeling, for machine learning, for data cleaning, all the processes or function you can search in the operator window, and you will be given with that particular operator, and you have to identify, select it. And the repository part, this is totally data oriented or process oriented. Means if you have any data or process saved in your repository or in a hard drive, you can access that from this particular window. And this portion is the main one, that is called the process window, where you will be bringing all the different tools that will be used in your this RapidMiner studio for your means own purpose, for your own model creation. All will be done over here in this particular process window. And the right side, this is the parameter window, which is also very important. Whenever you would like to customize the default parameter of any particular like operator. Okay, so that particular means operator may be customized here. So operator means the functions, repository means the data or the process, and parameters means customization, means feature of any particular operator. So to bring any particular data, so let us go to the help section directly. So let us start with, I have already said the access data, and let me give it filtering and sorting. Okay, so let me start with this. So once you do this, you can find that in the process window, a dashed box are coming over here. Okay, so here these symbols, the dash boxes, are actually giving you an indication that you need to drag or you need to include some process. Now, as it is a tutorial, here these dash boxes are mentioned that what operator you have to take over here. But if it is a new one, your own new project, then nothing will be mentioned over here. It is a blank. You have to decide the pipeline or the sequence in which actually you have to bring the operator. So here my purpose is, in this particular tutorial, I have discussed this in the previous main session yesterday, but quick revision of that, because from here I can, and you can understand the pipeline, that how it works. So this retrieve Titanic dataset, I have already said the Titanic dataset is a dataset which is already available in the repository of this particular set. Okay, so here from this repository you can find a folder called sample data, and there are, these are all sample data sets with which you can do some experiment. So here in the repository you are asking like retrieve means fetching. So retrieve Titanic means it is asking you to retrieve the Titanic dataset which is available in the repository. Okay, so if you just drag and the Titanic dataset over here, it will be set. So retrieve means importing. So whatever in Python programming we write now, that import or like that, or something whenever you read CSV into some pandas data frames or numpy data frame, so that thing is done over here, that with the help of this your Excel file dataset is now has become a part of my process that I'm making. Okay, so once you do this, you can make this repository this window. Okay, so if you click that particular bubble, out bubble, so here you can get an understanding, a brief like visualization, a brief description of that particular data set. So here you can get an idea that in this particular data set, you can have that 1309 number of examples are there, 12 attributes are there. That means in this particular data set, you have 12 columns and 1309 of examples. So those who are means have this tool ready, are they able to do this with me? Is it there? Is it working? Is somebody doing with me what I am doing? Are you able to find that particular help? Or if it is not, okay, someone is doing, they have said given me response. Anyone else? I have got response from one. Two have given the response. Okay, 3, 4, very good. So many of you are doing. Now here I have said, different operators are there. Okay, n number of means operators are there. I was searching also. So get a more detail about that. What are the different types of operators are available? You can have some. This you can visit this documentation page, or you can have that Altair Rapid Miner Academy web. Okay, you can also find in YouTube for different tutorials as well. Now it is showing you that my purpose is to find out the highest fare paid by any man or woman. Okay, so this is my data set. Now I have to filter it. Filter it for whom? Filter it for women. So as I am asking a data specifically for women, so what I will be doing, so here I have to find out another operator called filter example. So for that, what I will do, I will directly go to the operator tab over here, operator window, and search for this operator called filter examples. So FILER. So whenever you give filter examples, you will be finding that there is a filter example operator under this filter section. So simply drag and drop over here. Okay, so there are some channels you can find, some bubbles. So bubbles are the connectors. So the bubble that is out bubble of this retrieve tightening dataset, you have to connect it with the filter example operator. So just either you can drag or just double click, once click the retrieve tightening out and in the example port of the filter example. So once you click twice, this these two bubbles will be connected. Now when these two bubbles are connected means what? Now this retrieve tightening means tightening dataset now available with this filter example operator. So once you just click it, you do not have to do anything. You will be finding a parameter list at the right hand side. Okay, so here my purpose is to do what? Add some filters for women. So here you can find that whenever I have clicked, again I am showing you that what I am doing. So if someone is not able to understand what I am saying, or my audience means audio is not clear, so or you are missing something, you can also check that left hand side window for guideline that what you have to do. Okay, so here what I have to do, I have to select that add filter. So I am making filter for what? I am making filter for gender. Okay, so select this particular box and I would like to make a filter based on what? Sex or gender. So if I would like to make a filter regarding age, I can also have a particular case. If I want to make a filter ticket number or passenger fare, I can select this. So here I am doing a option. I wanted to filter with the help of this based on the sex column. So sex or gender equal to what? I have to write here female. So what will be that particular spelling? of this particular female, because for this particular purpose you have to check the original data set. What was the spelling or case of that female like send a text in that particular data set. So you have to give over here this exactly in the same way. So once that is done, you just click the OK button. Okay. And here also, now you need what? You need another operator which will sort. Okay. Now, after this filter example, now this operator had a full tightening data set. Now in this, now once I have configured this particular parameter list of this example operator, filter example operator, now this is having data only of women, a female passengers. Okay. Now from these female passengers, I would like to now sort. So for this, I need a sort operator. So I will do what? I will go search for sort operator, drag it over here. Okay. Then connect the bubble. Okay. Now, one more thing, once you have to run this any particular process, you have to connect it with this result, small result bubble at the rightmost part of the window of process window. Okay. So you always have to connect this. Otherwise, this process will not work. Okay. So once it is sort, then you have to mention over here that what attribute you are going to sort. So what I am doing here, anyone will respond, what was my target? Which attribute I am going to sort for female? Anyone? Which attribute I am going to sort? They are all different. Which one I would like to check? Anyone please give response? Fair. Okay. Somebody has given responded. Very good. So fair. So here I would like to select that passenger fair. And as my own requirement ascending or descending. So here I will say descending. Okay. So now everything is set. So once everything is set, then I will go to this run button. And once I will play, I will be finding that this is my resultant data set for all female passengers, and this passenger fare in a sorted way, descending in descending order. Okay. Clear? So this is one thing. Now I can do this. Now let me go to that filtering, sorting, merging and grouping. Okay, so this is also very important thing before I do, but it is not required for all cases. But for merging and grouping, here we will be using a different data set. Means what we need to do, if we need to here, you just go to the repository. In repository, you are being asked if you can check. You are being asked to the dataset of retrieve product. Retrieve means bring or import. So products and transactions. So you have these two dataset which you need to bring over here. So here what you are doing, main purpose is I have two dataset, products and transaction of that particular product. I will join these two dataset and aggregate. Okay. So let me check, show you, then the idea will be clear. So retrieve product, search over here. So where is product? Here. The product data set I have found. So just drag that particular product data set here, and you also retrieve transactions. So it is asking about transactions as well. Okay. So now obviously you can see you have to connect the bubble, but before that you need a join operator as well. So search for the join operator. So where you will search? You will search here. So search for join operator. Now join is something like a database join. Those who are familiar with DBMS, they can understand this thing very well. But means it is joining to different tables. Now whenever I will join two tables, I need some primary key. So based on which I will join, because this is have some data set. So let me check with this data set. First, this make this tool inactive, and one by one check what these data sets are giving us. So when I am saying checking this particular product data set, I will be finding that there are four columns like product ID, product name, product category, and its price. Okay, and it is having a detail of 178 customers maybe, or products, whatever it is. Okay, now go to that, close it, and check it for what we have here for this retrieve transaction data set. So here what we have? Here we have customer ID, product ID, and amount. Means if I find that previous data set has that how many product or which product with product ID was sold in how much quantity, that particular data we had in the previous. Here that which product ID is purchased by which customer and in which what amount, means how many of that particular item that particular customer had purchased. Now I want to join these two. I would like to check that as here my so once I will join. So let bring back the join operator in its position and make it active. Then connect. Okay. Now once you click join, go to its parameter. Okay. Now when you go to the parameter field, we will be finding different options. So here join is inner, outer, left, like right, different joins are there. So keep it out there. Find the key attributes field. So here you will go there, and this where you will be finding two key attribute, left key and right key attribute. Okay, means which based on which key or which column you would like to join these two tables. So obviously product ID is common in both the tables and product ID is the primary key. So I will join this with the help of product ID. So here product ID and the product ID in both the cases I have made. So now once I have done this, now these two tables, but these two data sets are now joined with the help of product ID. Okay. Now here in the left hand side, you can have some more details or discussion about aggregate, what this aggregate operator will do. It is written here clearly that aggregate performs a group by function that you may know from database. Okay. So the aggregate function is one of the most important operator for data blending. So data blending, I was talking in the data preprocessing part. So where data from multiple sources are coming and you have to combine. So in this case, it groups the data by product, counts the number of purchases for each product, and uses the product name for describing this particular product. So this is my aggregate function, what I need to do over here. Now search for aggregate. So you'll be getting an aggregate function over here. Connect it. Also connect with the result. Click on this aggregate. Now I have to check that what should be my aggregate attributes. So here go to the aggregate attributes part, mean how I will aggregate these two particular values. So here my aggregate attribute will be the customer ID. So based on customer ID, I will be doing. Okay, and obviously I will be using average function. So means for a group, how much product as an average it is purchased. So once you apply it, then connect and then run it. here I have to add another entry. Okay, so like which product, for product name also I'm doing now. So product name, so here I will be applying mode. So mode means most frequently, that is what, apply over here and then run it.
Can you please show join attributes screen?
Yes,
Attribute screen for join. Can you please show?
yes.
Left and right, what we kept? We kept
Product ID.
product ID
Yes,
and the customer ID. Customer ID is not on the right. Or both product ID.
both product ID.
Oh. In both the tables, product ID is only available, so we kept
Yes,
product
yes.
ID.
It is common. It is the primary key. So it will be
Okay.
joining with that particular product ID.
Oh, okay. Both the tables, product ID is coming, so we have to give product ID
Hmm.
in both. Correct?
Yes, yes, yes.
Okay, sir.
Which
Thank
is
you
the
very much.
unique identifier.
Okay, understand. And in aggregate, what we kept? Aggregate.
Where?
In aggregate, the inner columns.
So in the aggregation attribute, we have selected two attributes.
Oh.
Customer ID
Hmm.
with function as count,
Hmm.
that how many number of product that particular product was purchased, another is product name which was frequently purchased. So these two things. And once it is done, you'll be finding so it is the product ATH, SAT, whatever it is showing. And that was purchased in quantity of 2328. So it will be giving you a brief description of aggregation like this. So now let us move on to merging and grouping, creating and removing columns, changing the data types of rows. So we will not go here. So directly we'll move to the prepared data. Okay. Okay, so we will now go back to our Titanic dataset that was already available in the repository. So here what I will do, that I was talking about the missing value replacement and data as a part of data pre-processing. So we will check over here how to do that particular thing. Okay, so initially what I will do, again I will be retrieving that Titanic dataset, take it over here, and once I connect at that particular result part, and if I run it, I'll be finding that if you go to the statistics part and check the missing column over here. In the missing column, you'll be finding that age column is having 263 missing entries. Okay, here we have total of 1309 examples. So I have a details of 1309 passengers, and among the 1309 passengers, age is not available for 263 passengers. Cabin information is not available for 100 means 1014 passengers. Port embarkation is not available for 2 passengers. Okay, but here the major are these two, like age and the cabin, and maximum missing value came. So as I have mentioned in the pre-processing discussion, that if we keep these missing values in my data set and give it directly to the training, it will create problem. So I have to tackle it. How to do this? I have said different processes, and I will check how to do this. Okay. So let us distribute. Now the select attribute part. See, this select attribute is very important. You just all know that these attributes you have to use frequently in your models, because in the data set, maybe that all attributes are not similarly important, or sometimes some attributes are irrelevant. Now, suppose, let me show you this data set once again. Now, suppose my target is to predict the survival, okay? Survived. That who have survived, who have not. So if this is my target value, now can anyone tell me that which of this among these all these how many 12 attributes, among these 12 attributes one is survived, so the rest 11 attributes, which attributes are not relevant for this particular survival dependency? Means if my survive column is my dependent variables and all other my independent variables, so can anyone tell me that which of these independent variables are irrelevant for this?
Age and sex may be
Irrelevant. I am asking which are irrelevant, means which does not have any relation with whether the patient means passenger has survived or not.
I only told 11 ones, age and sex.
Yes, age and sex are irrelevant, not
No,
important.
relevant.
Relevant. I am asking about irrelevant. So rest are irrelevant.
Yeah, ticket number. Maybe ticket number is not.
Ticket number. Very good. Let me check any responses coming in the chat or not. Okay, ticket number, passenger fare, fare.
The port of embarkation may not be useful.
Hmm.
Fare paid may not be important.
See, it's very good. Many of you, that all of you have given the correct response. So at a glance, it's very clear that like obviously ticket number is irrelevant, but passenger fare is relevant, because based on passenger fare, the cabin was decided, and based on the cabin, the priority was decided. Those who have watched the Titanic movie, they can also understand. And the age and sex is also important, because age representing child. You can remember that particular dialogue, women and children first. So whenever the Titanic was sinking in that particular movie, so like, so these, so you the, and also the like port of embarkation may be relevant, maybe, but cabin, do you think it's relevant? Which cabin
Yeah,
was?
position of the cabin can be important.
Class or cabin? Passenger class or cabin? So cabin means here what are the different entries of cabin if you check? So
Cabin
cabin means
numbers.
here cabin numbers. So are they relevant?
Which floor? It will decide which floor. When it's 11.
But there is no mapping now with cabin number and floor. So here model have, we can understand that by checking the CD we can understand cabin, but model have no clue to check or understand whether what is the meaning of CD or something like that. And it is, do you think that cabin these values have any relation with this yes, no, or something like that? So these are numbers. Like ticket number, this is a cabin number. So if ticket number is irrelevant, the cabin number is also, because it is based on the sequence of that particular like how they have got that particular assignment of cabin numbers or allocation. Okay, so now one thing I can check, though I have not checked here whether this operator is available here or not, that is called correlation matrix. So let me check whether this is available or not, which will be giving you a clear indication. So let me check something whether correlation, because in Python we do. Okay, here correlation matrix is there. Very good. Let me select it. Okay, include attributes. I will be checking include attributes, all attributes. Move it. Select the matrix with the result. Okay. Type. Okay, this is the very good. Okay, here one problem is there. See, I was asked for designing a correlation matrix, but it immediately gave error. Do you know why? Because whenever it was trying to calculate correlation matrix, it found many missing elements or missing numbers in that particular cell. So here I do not have any idea. So before I generate the correlation matrix, let us remove all the missing numbers and then I will come back to this. This correlation matrix will give you an idea that which parameter is important for which particular purpose. So for the time being, I am removing this correlation matrix and I am making it disable. So once you have made it disable, whenever you will run the process, this operator will not be considered. But if you keep it disconnected and keep it somewhere in a different place of that particular process window and do not connect it, it will not allow you to run because it will give an error. So better option, which is not required for this timing, you just keep it inactive. Okay, so now as I was thinking that some parameters are not important. Okay, so like some cases, select attribute, come to that select attribute. Where is select attribute? Here. So drag and drop over here, and the select attribute, you just go to the subset. Whenever you click the subset and select attribute, here all the attributes or columns that are available in the dataset will be showing. Now from this, you may discard few which you find that these are not important. So for the time being, here what I am doing, maybe for suppose for example, I am discarding cabin and live boat. And rest I am considering. So how many attributes were there initially? Total? Can anyone remember?
12, initially 12.
Total 12. Now I have discarded how many? 2. So right now, if I execute, I'll be able to check 10 attributes now I'm having. And that particular 2, like cabin and live boat, these 2 columns are now removed from my data set, which are now not being considered. Okay, now let us again go back to the result part and check the missing values. So why I have removed missing cabin? Because cabin had a lot of missing values, so I have removed it. Now here I have 263 for age. So age is the major concern that I have to take care of. So now go to the replace missing value operator. So I have to search here that replace missing values, bring it here, connect it, and the replace missing values, you select the attribute filter type to be single because you are applying a single filter to replace that particular missing value, and which attribute you are considering, that age attribute. Okay, and how will you replace that age missing values? Now if you can remember, I had different options. So here see average, minimum, maximum, zero, value, something. So I will be using at the average one. Okay, so after doing this, connect, then execute. Okay, Now check at the missing column. See, here now age has no missing element. Earlier it was having 263, now it is now all replaced. Okay.
How did we manage that? How did we manage that? Okay, sorry.
Okay. So there was a missing replace value operator.
Hmm.
You select it and there attribute filter type. So you may applying that missing value elimination for only one parameter. You are now selecting for age only. So here you will be selecting single. Then select the attribute, that which attribute you are considering to replace missing values. So here it is age. Okay. And then how will you replace the missing value? So in the data preprocessing discussion, I was saying now that we may have different option to replace the missing value, either with 0 or a particular value or minimum of all the values in the column or average. Okay. So here I am doing it as average. So I will take the average of all other available entries and put that average in that particular age column or that particular entry. So once you have done this, is it clear now?
Yes, yes, yes.
Now once you run it, then you will be finding, if you go to the statistics part, then see age has no attribute as to be 0. So it is no missing element in my age right now. So missing value I have tackled. Now another thing is can be there, like here, see, I had to take some arrangement with the age because there were 263 passengers without age entry. So I cannot directly remove it, because if you remove it, my data set size will reduce by 263 at which it was. So still I have 1309 examples that I had. But if you check for other two entries like passenger fare and port embarkation, passenger fare column has only one missing entry, and it's one entry with missing element of passenger fare, and for port of embarkation, two missing. So I can easily remove this 2 plus 1, 3 rows. So it will not affect the data set largely. So for that particular purpose, I may use filter example. So search for filter example. Okay, so once you click the filter example part, here you will be finding, normally you will be able to check the parameter like this whenever you will be clicking filter example like this. But here at the bottom you will be having a link called show advanced parameters. You click that. So once you click that, you will be getting another entry called custom filter. So condition class. Okay. So condition class, here you will be giving no missing. See, here are many options: no missing attribute, no missing label, something like that. So our target will be to no missing attribute. So the attribute which is a missing value will be removed. So click here, no missing attribute. So anyone can remember how many entries were there? Total number of examples there? 1309. Now check. No missing entry. So this filter that did what? This filter removed those example which had missing entry. So 2 plus 1, 3, it had removed. So total 1309 examples of the passenger data were there. Now from there I have removed 3. So it is now 1306. Okay. Now let me check once again about that correlation matrix, whether it works or not. So let me enable it again. Okay. Take the parameters. Include attributes. Attribute types. Here I will select a subset. Means because all are not important, I will check the correlation with age, passenger class, passenger fare, ticket number is not important, survived. Number of passengers, siblings like this. Okay, port of embarkation is also not important. So I have selected only these variables. Then apply. Then matrix with this. Yes. So passenger name, these were there's a what I call categorical variables that is not coming. So here you can think that the values which is having higher or lower, higher negative or higher positive, these value is representing higher correlation. So highest correlation is 1. So that is because all diagonal values of this particular matrix, correlation matrix is 1, as you all know. But look at here. Like if I am talking about survived, so here age and survived. So it is a correlation, it is showing as 0.052. Gender and survived, it is 0.52. It is much higher. Means there was a correlation between gender and survived. So if you check the data set, most female passengers were survived. So from the data set, gender and survived, there is a higher correlation. Then passenger fare is having negative correlation. Meaning what? Means low passenger fare, low survival rate. Higher passenger fare, higher survival rate. That means passengers with higher class, like were prioritized, and they were more survivals from passengers in higher classes. So here passengers class, as there are numeric values are there, no numeric values are there, that's why you are not able to find out. So that can be rectified whenever I will be imputing that particular value with some other purposes. So this is an example that how you can do this. Now I will do that.
Yeah,
numeric
one second,
value.
sir. One
Yes.
second. This correlation matrix output is having 3 boxes, 3 bubbles. So you took the center one and connected it with the result.
Yeah,
Why?
that is why it is called matrix. MAT stands for matrix. So I want the
Oh.
matrix.
First one. What is the first one? Then.
First one is for example.
Oh. And what last one is?
Wait, WEIGHT, it's something.
Okay. And how to make the screen split for parameters? Process is only coming always full screen, but parameters as a box. How to bring it there?
Okay, you can use this right click on that parameter and click that option detach.
And no, my question is, sir, initially process is one screen. In that part of that, I should be getting parameters. How to make it happen?
I didn't understand. Parameters means
Uh,
is
how
once
how
you
to?
click on the process. Click on the process and the parameter list will be opening at the right hand side.
Once you click on the process. Okay. Let me see.
Yes.
Okay.
You all check. So are you all following? Those who are having, please give your response. Little bit comfortability. How to gather the operators, parameters, data.
Still, the parameter is not coming. As a split for the process box, parameter is not coming. That's the question I was asking, sir.
Okay, you just please share your screen with me.
Yeah. Are you able to visualize my screen? Is it visible?
Yes, yes.
You said by clicking the process screen,
Okay.
it will.
I think it is now disabled by you, unfortunately, but somehow. You go to the view tab,
The view. Yeah, view.
then show panel,
Show panel.
then click the parameters.
Show panel.
Yes. Now it has opened at the bottom. You check left. Not there.
Yeah. It has come
Yes,
here.
yes. You just drag there and put it in the right side. Click on the parameter text. Yes.
Now it is taking full screen. It is occupying. That's the problem.
How it
So.
happens because you just close it from there because it is integrated in that particular tab.
Okay. View I have to use and show panel. Then I have to parameters I have to click. Then
Yes.
it's coming here. Now in order
You
to
just
keep it on the yeah.
you just drag, click on the parameter, not cross
Uh,
sign, parameter text. You click. Otherwise, it will be closed. Don't take the cross. Leave it.
yeah. I have to click here and I have to drag it, isn't it? Drag
Uh,
it. Now it's okay.
Not there. Now it has. Now it is there in the left side. No problem.
Okay. Okay. I have to.
Wherever you're pasting, it will be adjusting accordingly.
Okay. Thank you. But here it is coming as a full screen. That's the problem. Let me see. I have to play with it and find out how I will do that. So I got it. View I have to include. Understood.
Yes, view show panel.
Uh-huh. No. Yes. Okay.
Okay. So now please stop sharing so that I can share my screen as well.
Yeah. Yes, sir. Sorry. Thank you very much.
No, it's okay.
I have left screen sharing. I have left.
Okay, sure. Thank you. Now I will build a model. So prepare data almost we have done. Sampling, pivoting. Okay, normalization and outlier detection. So come back to this. 45 minutes more. It's not saving anything. So here, identification of means normalization that I was saying. Normalization means range manipulation. Okay, so if you can remember in the data preprocessing part in the beginning today, I was discussing about this. So again, the same process. I will ask all of you do to the first two step before me and with me as well. So retrieve Titanic, select attribute, connect it. In the attribute selection, I will not include parameter a subset, and other than cabin, lifeboat, name, ticket number, all these things I will exclude. Okay, ticket number, cabin, lifeboat, name, all are not important for me right now. So remove it. Okay. Now let me check the condition. Okay, one more thing. Okay, here is another operator called statistics, which you can bring. Here with this statistics value, you can have more insight on this particular data set, any data set. Okay, these statistics will be giving you a histogram plot and also the minimum, maximum, average and standard deviation. Why I am showing you this? Because this will help you to understand what is the requirement of like normalization. So for age, you can find minimum value is this, maximum value is 80, average is more or less this, standard deviation is 14. Here also minimum 0.9, you check all and the standard deviation. Here also 0.8, 0.499 and standard deviation is 0.04. Passenger class, this is a categorical valuable, so that's why variable, that's why it is showing the count and percentage. Here passenger fare, a lot of standard deviation is very high. This is a categorical variable. This is a gender. So this is also a categorical variable. And the survive, this is a categorical variable, no problem. Now, our target here is to reduce this standard deviation, means making the standard deviation 1 and mean to be 0. That is my our purpose. So average to be 0 and this is to be 1. So let us check how we can achieve this. So I will disconnect this for the time being. I will check the statistics later on after normalization. So here now my target will be to go to the normalize. So if you can remember that in the normalization discussion, I was talking about Z transformation. Okay, so here I'll be applying the Z transformation over here, and here attribute type, though I have given all, but I can also given a subset because it will be applying normalization wherever it is applied. All means all attribute will be considered. Whenever I'll be clicking subset, it will be asked you to select the subsets which you would like to normalize. Like here, if I select the attributes, obviously I can understand only this parameters are eligible for normalization. Okay, so by default it is only 4. So that's why I should give all, no problem with that. So once you do this, okay, leave it now. For the time being, let us make it active. Now see here, age, the average becomes 0 and standard deviation have become 1. So this was the Z score normalization, which is now applied to my data set. 0, 1, 0, 1. These were the categorical variables. Here, this is again a numeric variable, that is passenger fare 0, 1. So did you all understand that how normalization is applied here with that particular normalization operator? And the things are very easy. Okay. But only thing you have to remember the name of the tools or operators which I will be using. An outlier also. So here I am removing this statistic operator because this is just for understanding, it is not of no use. So detect outlier distances, because you just check it, detect outlier. So there are different of detect outlier distances, dense sites, different options are there. Here I will be using this one, statistical thing. Okay, so once I detect outlier like this, and once I click its parameter, now number of neighbors 10, number of outliers 10. So means it will be checking 10 neighbors and identify the 10 outliers. So, and for just simply I will be using Euclidean distance for outlier detection, that how far it is from its neighbors. So based on that, it will be now identifying the checking the 10 outliers from it. Okay. So here to filter example. So connect filter example, and here add one more filter, new filter. Here another filter at the bottom you can check called outlier, okay, and equals to false. Means I will be filtering out those examples which are not outliers. Okay, I'll be showing you. So if I give here false, that means what? What is expected? Can anyone tell me? Means my target is to consider the filter out the examples which are not outlier. So how many data set we are expecting? Means how many examples we are expecting after this exercise? So total number of data were how much?
1039.
Yes. Now from there, I have excluded 1309 were there and 10 I have excluded. The top 10 means 10 outliers I have removed. So that's why it is now 1299. So here I consider outlier is false, false, false. Everywhere giving means these are not outliers. The 10 outliers are removed. Okay. Now if I would like to check only the outliers, so here I will be doing filter is already there. So here outlier is true. If I give, then obviously you can understand it will show only 10. Only 10 because these are the outliers I would like to check here, that what were the outliers that are detected. So these 10 entries are found to be the outliers. So here just by checking or dealing with this two variables, like here I can make it false or outliers greater than this or something like that. I can do many things, and detect outlier I can select here 20. Also I can remove. So it's based on your choice. Okay, that how you are actually trying to deal with that. So so far is it clear to everybody? Okay, now already missing value enumeration. So in the pre-processing part, what we have done, we have select attribute selection we have made, we have performed missing value elimination, we have performed normalization, we have also performed outlier detection. So the necessary steps that are required that we have already made somehow. Now let us go to directly changing the type and pivot. I am not discussing here. Rest of the things you will be practicing. Okay. Now go to the prediction modeling. Okay. Here, simply without any kind of means, what I say, any kind of pre-processing or something, we can directly apply, and we will be checking very confusing model. Okay, but we will be getting some idea about what is happening. So see here, if you do not process it, so you have seen already the Titanic data set I have shown you already. Now here in the sample data set, you will be finding a data set of Titanic training. So this Titanic training means it is made ready for training itself. So obviously if it is ready for training, it should be pre-processed, isn't it? So let me check. I have not checked yet, but let me check. It should be pre-processed. It is somehow pre-processed. You have, because only relevant features are there, 1, 2, 3, 4, 5, 6, and you can also see that survived this field as selected as label. I will be showing you how to do this. Label means this should be my target variable. Okay, no missing elements over here, and average all are numeric. So here normalization is not done yet. Probably they have not done it. Okay, what we will be doing in our cases. but it is segregated, no problem. So here training data set is taken and retrieved. Then decision tree, naive-based rule induction. These are all supervised learning methods. Already I have mentioned in some cases. Like naive-based is a means probability-based, like conditional probability-based theorem. Okay, I think those who are from statistics and mathematics, they can remember the Bayes theorem. So this classifier is actually uses Bayes theorem in its process. So decision tree, I can search. Can connect it. Now see here, three models. It is not joined by cascading. Three different models I am using over here. Okay. So I will be checking the performance of each. So naive Bayes, and another is rule induction. So this example to training connection means what? I am just transferring this value here, this value here. So same example is being used by all the classifier models. Now, based on with the model I have to connect, it will be given. So first I am connecting the decision tree with the result. So once I do this, run this, it will be showing, giving you the decision tree, if you can remember. So it has given you the full decision tree of that particular problem. And from here you can easily understand that the in the cases of female, the survival rate was high. Female with high passenger fare, you can find that there was higher rate of survival. But for the male, sorry, for the male, the survival rate is very, very poor in that particular case. So this is a kind of a glimpse you can understand. And you can also see here maximum depth of the decision tree from the parameter list. You can make it here, it is 10, you can make it 5 or suppose 4. So in that case, decision tree will be little bit shallow. Okay. So here you can find that obviously it is very clear the passenger with female passengers having a higher rate of survival, where male had very less. Now I can extend the depth of based on increasing the depth as well. I can disconnect this and I can check the perform of this application of naive based model, run it. So here also you can check the distribution of this naive based probability classifier. So it is as it is not discussed, so I will not. But here you can understand that based on age, we can find that yes comes under particular this category. So plot view, here it will be clear. So this distribution will be easy to understand that within this range, this red line is showing that no survival, and this blue line is showing the survival actually. So lower age survive more. If I consider the passenger class, so we can easily find that no third class passenger were the most affected one and they were not survived most of the cases. And blue, higher blue tower means passenger with higher class, like in first class, they survived. So this is an interpretation. We can draw different interpretation. And rule-based classifier, it is again a very important, which will be finding some rules. And if you check these rules, it is very insightful. Like when the if the sex equals to male and passenger fare is less than 26, then no is 57 and yes is 367. So it is very clear that when the gender was male and passenger fare was less means third class male passengers. So maximum died. Okay. And female passengers first class, then maximum survive. It's 97 versus 4. When among them 97 survive, 4 lost their life. But here it is 57 among means 367, actually 57 survived and 367 died. So here this rule base can give you a greater insight here for this situation, that how these parameters are influencing the target variable. So as I am running out of time, so I will ask you to explore it more, but just complete this exercise. I'll be giving you the 5 minutes of time. Then I will be doing a full exercise of another data set, just taking it from hard drive and the complete process. So in between, I will request all the participants, those who are actually doing this practicals, they just complete this build model. Okay, 10 split validation part. So modeling, I have scoring. These three, I will request you to execute and check. If you face any difficulty, then let me know. I'll be back within 5 minutes, and I hope that you will be doing that. Okay, so let us resume. Any question from the audience? Because I can find that someone has raised the hand. Okay, I can. I hope that you can see my screen. Anyone, please confirm. Okay, good. So, were you performing the task that were given in the tutorial? Are you able to apply that? What was written? Okay, so let us take a complete example or a scenario which will help you to grasp the overall situation. So here I have already made a like pipeline, because this pipeline is very much important for any kind of machine learning model to understand. So here I have used a data set. Okay. There is a cancer data set that is downloaded from Kaggle, where actually different parameters of tumors are given. So let me save it and start a new blank process just to show you the data set. Okay, so sample local repository data, this one. So this was the data set. You can find total 32 parameters or attributes are available, and total samples of 569 samples are there, and more or less no missing value was there. So this is a very good data set. Normally we use for learning classification. Okay, and here you can easily understand because I have all numeric values. So if you go for like what I say statistics, or sorry, confusion matrix, like sorry, correlation. Now this is showing you a very good correlation matrix uh, of that particular data set, and you can find that uh, more or less all parameters are influencing my like diagnosis. So this is the diagnosis parameter. So to a certain extent, so here 32 parameters, all are how they are correlated with each other. We have it is clearly mentioned. Now negative correlation, high negative correlation, and high positive correlation, all are very much important, as you all know. So these are negative correlations, and at this point there are higher correlations you can find as well. Okay, so this can give a very good idea about that, and like already have shown you. Now what are the process? What is the process? File process. Open process. Repository, local repository. Okay, so here I have just uploaded the data set. Then I have selected the attributes. Now include attributes. You can see here that other than the ID, because ID is irrelevant. So I have used all other attributes other than the ID. So I have selected the attribute. Then I have converted them to nominal to binomial. Why? Because if it is other than it is not a binomial parameter, it will not be used for by the classifier properly. So I have to convert this to nominal to binomial. Okay, so this is an operator what we have done over here, and here also. Then here the set role that I didn't discuss earlier. Set role means which label, which among those columns and features you are going to predict as your target class, or which will be your target class, means predicted level. So here I have selected the diagnosis as my attribute name, which is going to my target role, means level. So this will be my the dependent variable that I am going to predict. Okay, so this can be done like in a Titanic data set, the predict level was there survived. So at that time we could have set role of that survived feature column to be a like target role or the level target level. So here that set role, then the normalization, as I have already shared you, we have already done it. Okay. Now here the split data. The split data is again an important thing. So means I had whatever the data set I had here, I have added two entries. Like the total data will be divided into 80% will be used for training and 20% will be used for testing. So I'm splitting the whole data set because as I have said now that I have taken the like for Titanic data set I had total 12 how much 1299. So all were cannot be used directly for training because we have to keep normally few for testing purpose also. So this is the place where we can divide the ratio of training and testing. So among whatever amount of data you'll be having, 80% of them will be used for training and 20% will be used for testing. So that can be done with the help of this split data. And after that, there is a cross validation. Okay, you can also skip this cross validation because I'll show you this cross validation. If you double click on it, you will get two portions. One is training and another is the testing purpose. So training here, I am using a logistic regression operator. So once you search over here, logistic regression. So this logistic regression I have used. You can also use logistic regression SVM also. So logistic regression, and I have connected the training data here as a training. Then you can change the parameters according to your own need, but for that you need to know the parameters, and then connect it with the model. Okay, then from here to the apply model. Apply model means this model will be applied on that particular data based on your standard split, and this is the particular portion where you will be measuring the accuracy of that particular performance. Okay, so here I have only selected the accuracy portion. So once it is clicked, it will be showing the accuracy. Now I can just by clicking this icon, I can move back to my previous window, and then finally this performance you can connect it to that particular result as well. Or here you can check the model. It will not work properly, I think. See here, when I have run it, it is showing the accuracy. So this is the confusion matrix that I was discussing, if you can remember. So you can check that how many percentage, like this is a true positive cases, like predicted means malignant, true malignant, it is 163 cases. And like it was predicted malignant but true benign, there is false negative cases, it is 14. Okay, that is predicted benign but true malignant, it is 11, and it is something like so. This confusion matrix already I have discussed earlier, so I will not repeat it. So again, class recall, class precision, all you can find from this particular performance. Okay, so in this way the whole pipeline can be uh, designed. Okay, so these are the different steps that we need to follow. So just download the data, put it, select the attribute. If you have to select the attribute, then check the values whether they are nominal or binomial. If it is not, convert into the binomial. For the categorical variables, then set role. Obviously here like missing value elimination things will be there. Okay, so you can apply that operator as well. So as we didn't have any kind of missing values over here, so I didn't apply that. Then normalize the data, then split the data into train and test, then apply the model, and then check its performance. So it is the overall thing. And one thing you can easily understand that this tool, I am telling you, it is very effective one for those who would like to quickly apply their means ML or data analysis in their own domain. They can quickly do this. They can try with some different data, with some different operators. Different materials are available online, as well as some YouTube videos also you can follow. You can reach to me also in future in my email, through my email, if you face any kind of doubt or understanding regarding any kind of model, email model or something like that. Okay, in future. So these are the things you need to explore. This is a very good tool, as I'm saying. It is having a lot of functionalities, and the best version you have downloaded, the 2026 version, the latest one. And I will suggest that all of you at least explore its functionality one by one, because it is simply connecting all the things. You need to know the parameters, check the performance. Okay, and here also you can because once you will be doing this tutorial, like build a model, this cross validation and checking. Okay, so these three, whenever you'll be doing this, you'll be able to understand that how the things are happening also. So this exercise will be helping you a lot to understand the performance, how the performance are checked. And here also you can give your new data set after a model is means built properly. Then you can test this model with your new data set, check the performance, draw some kind of insights like this. So once it is designed, you can also save your model, like file save as you are doing. I have done. So this will be helping you in future also to apply this tool in your own domain. Those who are in different industry, and for the academicians, I will be suggesting that you can demonstrate this tool in front of students to give an idea of ML pipeline and how the things works without any particular code. But obviously, those who are not familiar with coding, so they can use this tool. But those who are from computer science background or any engineering background, having some idea of coding, coding is always advantageous. You have a lot of customization opportunity, flexibility, and it is having something different, like feel when you will be coding some ML models in Python or in some other languages. But this is the best suited for experienced industry people who will be applying, who are deciding to incorporate AI in their own domain as well. So before I conclude today, I would like to ask the audience if you have any questions regarding this or discussion or from any topic that we have discussed so far, and share your opinion. Any comment?
It was really good, sir. It was really good. Session was useful.
Thank you, sir. Thank you for your feedback. I would like to hear from others as well. So I think those who were new to this particular domain have got some idea about what AI is and how it actually, because we had already a lot of different perceptions, like AI is this, AI is that, it is something like, uh, but I think the components, these different characteristics, this application, now this very beginner level you have now understood, and you can explain others as well that these are the things, these are the landscape, these are different components of AI and how you can leverage its power in your own domain. Any other comment or question from other participants? Thank you, ma'am, Sasmita ma'am, for your feedback. No, Mr. Murli J, we cannot code in this tool. If you are comfortable in coding, I will always suggest what I prefer, that is Python VS Code combination with GNAI means add-ons. That is the most best option with Copilot. So that is specifically for the programmers or the coders who would like to design models from scratch. But for other business and other purposes, for quick referencing, quick analysis, this is the best. Any special comment or like question you would like to add? Mr. Mahesh, do you have any questions? Your hand is raised.
Sir, no, I don't have any question.
Okay. Okay. Thank you. Thank you. Okay, then, Mr. Datta. It's now what do you if the audience doesn't have any question?
Okay, sir. All right. Thank you so much once again for the wonderful 4 day sessions. And this is, in fact, a very long duration being online session of 10 hours. And all the participants are working professionals. And so the resource person, very busy generally, weekends we need to spend with the family and the kids. But still, the passion for learning and that kept us all engaged for all the 4 weekends. And this itself, it shows the interest and the passion and the drive to learn new things. And definitely, as Elon Musk said, and we see on the social media that maybe in the 10 days, there won't be any job available to the humankind because most of the things will be taken care by artificial intelligence. And it's true. That's what Sundar Pichai also said, that it should not burst. Okay, the bubble, if it bursts, what will happen to the workforce? So there are a lot of forecast and a lot of emerging trends also, and it's impacting on the industry as well. Not repetitive work, okay, but there are so many other areas. You see that developers, they're losing their job because most of the developments can be done even for academia especially. I think a lot of repetitive things are taken care by the artificial intelligence. But having said that, the role of teachers, it cannot be replaced because we can data needs to be processed, needs to be adapted and delivered to the students. Okay, that option will be there, but no, teacher's role will change over a period of time. They'll be more like storyteller, narrator, explainer, okay, beside teaching or the content delivery. And that's going to happen 100%. Okay, that's the trend, how it shows. So let our fingers keep crossed. And wonderful session, lot of learning. As I said before that along with IIIE and MTC Global, we have planned in a series, and Mitra sir also given his consent, okay, for all the 3 programs, intermediate and the advanced level. And I'm sure that with these 3 programs, okay, we'll be equipped. Okay, I don't say that expert because a lot of things are, development is happening, rapid development in the AI space as well. But we'll be fully equipped to learn the new things, and also usage and the application part. I think that's very, very critical. So on behalf of MTC Global family and the IIIE, I extend our heartfelt thanks to all the esteemed participants, very senior participants. Okay, I would like to mention once again, we have Dr. Mahesh Karajikar sir, who was the former CEO of Al Ubaid Pharmacy Dubai, a very learned and senior industry professional, and so on and so forth. Very senior academicians also like Dr. Sasmita, okay, Vice Chairman of IIIE, and many research scholars. Okay, so it's a very mixed kind of, from corporate also, so many participants are there. It's a mixed profile, highly heterogeneous, so good for learning and interaction. Okay, we can see the industry academic collaboration is happening in this program. Okay, right interface.
Thank you,
And
Datta. Thank you, Bholanath ji.
and we have its pleasure that chairman of IIIE, Dr. Prasada Raju sir, joined us to say a few words to conclude the session. And I have just posted one feedback form. I request everyone to kindly give your feedback so that the next 2 programs we can here and there a little bit, we can do the upgradation. That's one part. The last part, the certificate is already under process, and we'll see that from today, okay, within next 3 days. I'm sure that it won't take next 3 days, maybe tomorrow or day after tomorrow, all the certificates will be sent. And I request not to leave the WhatsApp group until you receive your certificate. Thank you so much once again from my side. Now I hand over to Raju sir to officially say a few words, vote of thanks, and conclude the session. After that, we'll switch off. Thank you so much once again. Namaskar from Bangalore.
Thank you, Dr. Bolanath Dattaji, and really fantastic. 10 hours, really, it was mesmerized and very neatly explained. I hope all participants are enthusiastic to learn more and more. I request Gauri Sundaji, Mitra, to continue with us further, and I request especially participants to enrich your knowledge further in this field. Please continue with us, and thank you once again. And my heartfelt, really good appreciations to my team under Dr. Sashmita for doing this activity in a wonderful manner. Once again, thank you all. Good night.
Good night.
Thank you. Good night. Jai
sir.
Hind.
Thank you.
Bye bye. Going off the air. Thank you.
Okay, thank you so much.